All right, so in this video, I'm going to go over some problems that deal with how we can use calculus to answer problems dealing with kinematics. So kinematics is an area in physics that basically deals with motion. So like, position, like velocity, acceleration, speed, stuff like that. And usually in the calculus course, you're going to have problems that deal with kinematics. So it's pretty common to see problems about velocity, acceleration, position, because it's a very useful application of calculus. Now, depending on obviously your course or your professor or teacher, they may choose to put more problems dealing with kinematics than not. But I know in AP calculus, on the AP exam, there's usually going to be like a free response problem that will be based on the laws of kinematics. So it's very important that you guys know this stuff if you're in an AP calculus course. So anyways, okay, so what we have here is we're talking about instantaneous velocity. And what that means is that at a fixed moment in time, an instant in time, so an immeasurable amount of time, we can calculate the instantaneous velocity, we say. So basically, we can basically get an idea of how fast an object is moving. Now, the instantaneous velocity function is the derivative of the position function, because again, velocity describes how your position is changing. So commonly it's written as v of t, and position is commonly written as s of t. So s prime of t is going to be v of t. And we use, this limit expression to formally define instantaneous velocity, because again, an instant in time, basically when time goes to zero, so the change in time goes to zero. So the position you are at, you can call this at time 2, and where you are at time 1. Now the speed of an object is essentially the velocity of an object. However, when we talk about velocity in physics, velocity has a direction. So let's say you're driving on the freeway and you're going 60 miles per hour westbound. You would say, maybe let's say you would say that, your velocity is 60 miles per hour. Now, if a car was going in the opposite directions, but they were also traveling 60 miles per hour, even though their speed will be the same as yours, their velocity would actually be defined as negative 60 miles per hour, because velocity takes into account direction. So that's the main thing that you have to make sure you keep in mind, because in problems, when you're dealing with velocity calculations, you're going to be usually calculating position. And it's important that you understand whether or not negative values are going down or going to the left, and positive values are going up and to the right, that sort of thing. All right, so let's go ahead, let's do these practice problems. This will make this stuff much easier to understand. All right, so here we have a ball. It's dropped from a building 400 meters above the ground. All right, so sometimes you're going to get problems like this where they don't give you any background information about the essentially the position function, like the position function that's usually if you take a physics course, you'll learn, or you usually get like a formula sheet with this. We have s of t is defined as 1/2 gt squared plus v naught t plus s naught. This is a quadratic function, and it defines how projectiles fall on Earth, due to the force of gravity. So when we're talking about, a projectile, we're, talking about, how its position, what its position is above the ground, above the surface. So we're talking about like a vertical position. So, basically the position in the y direction. and it's 1/2 g t squared. This g is actually the speed of velocity. In meters, g is defined as -9.8 meters per second squared, because it's an acceleration characteristic. Now, again, depending on the problem, maybe you have to convert this to feet, but in this case, we only need to worry about meters. And again, know what V naught is. V naught is initial velocity, and S naught is initial position. Now, again, typically you'll get formula sheets in the physics course where you're going to have these, equations, so you can usually refer to them like that. All right. Okay, so we have this ball that's dropped from a building 450 meters above the ground. Now, again, since we're talking about, the position of the ball, being, how far it is above the ground, we're basically talking about, the vertical direction. So we're talking about, the Y, its Y value. So when it initially, its initial position is 450 meters above the ground. So we say S naught is 450. So, if we had a coordinate system, we would say that this is at 0, 450. You don't usually have to draw stuff, but just so you have a mental visualization, or it's 450 meters above the ground. So below this is be like the origin. Okay, now it's not given that you have any initial velocity, that that the ball is moving when you start measuring, its position. So we say V naught, initial velocity is 0. And so then we can rewrite our position equation, S of t as 1/2 times -9.8 t squared. Since V naught is 0, that goes away, doesn't matter, and S naught is 450, so plus 450. Or we can just say S of t is -4.9 t squared plus 450. Okay, so if you want to figure out the velocity of the ball after 5 seconds, you essentially want to see how the position function is changing after 5 seconds. Because remember, velocity, V of t, is the derivative of position, is S prime of t. So we're just going to find the derivative of S of t. So we want to find the derivative of the position, and then we're going to evaluate it for when t is 5. So first, let's find the equation for the S prime of t, so the velocity function. So using the power rule, we're going to have 2 times -4.9, so -9.8. Drop the power, so it becomes 2 times -4.9 times t to the 1, or just t. And the derivative of a constant of 450 is just 0. So your velocity equation is just this. Your velocity equation is just -9.8 t. And so we're trying to find the velocity at 5 seconds, after 5 seconds, so we're trying to find V of 5. So we just take -9.8 times 5. And that'll give us -49, and we say meters squared, or meters per second. Whoops, meters per second. Okay, so that's the answer for part A. Now, how fast is the ball traveling when it hits the ground? So for part B, you want to essentially find the velocity value at the time it hits the ground. So you have to first find how long it takes to hit the ground. Once you know how long it takes to hit the ground, you just then plug that value for t into the velocity equation, into this equation here. So first, let's find out how long it takes to hit the ground. Now, so remember, it starts at 450 meters above the ground. So we want to see how long it takes to get to, 0 meters above the ground. So how long does it take for the y value to go from 450 to 0? So we essentially are just going to solve for the zeros of the position function, because we want to see at what time t will this equation be equal to 0. So essentially we want to solve for s of t being equal to 0. So we're going to have 0 equal to then negative 4.9 t squared plus 450. We just solve this for t. So we have negative 450 over negative 4.9 equals t squared. We take the root of that, 450. Taking the root is the same as raising, or taking the square root is the same as raising this to the 1/2 power. And you'll get that t is about 9.58. So it takes the ball about 9.58 seconds to hit the ground. So now we just find the velocity value when t is 9.58. So we want to find v of 9.58. So then we just plug this 9.58 into this equation. Negative 9.8 times 9.58. And we'll get about negative 93.9. Again, you may get a little different if you round it. If you round your answer to like 9.58, but this will be a close enough answer. So about negative 93.91 meters per second. And yes, the negative sign does matter, because that negative lets you know that we're talking about the speed in the downward direction. All right, remember, velocity, the direction matters. So we say the velocity is about negative 93.91 meters per second. All right, so let's go through one more. All right, so we have another one at time 0. Diver jumps from a platform diving board at 30 feet above the ground, well, above the water, same sort of thing. Because the initial velocity of the diver is 16 feet per second, the position of the diver is s of t equals negative 16 t squared plus 16 t plus 32, where s is measured in feet and t is measured in seconds. So we have to answer 2 questions. When does the diver hit the water? And what is the diver's velocity at impact? Now, this is probably an easier version of the problem we just did. So that's kind of nice. So so you see how it says the diver has an initial velocity of 16 feet per second. And if you look back to our position equation, that v naught would be 16. That's why you see the 16 here. This is still like basically the negative 1/2 g, but since the g is or in this case the force of gravity would be in feet, or it would be measured in feet, but that that's taken care of, so we don't have to worry about that. Anyways, so so for this one, to find when does the diver hit the water, we just have to find when its position is 0. When is it 0 feet above the water? So when is s of t equal to 0? So we just solve this equation for the zeros. So we have 0 is equal to that. Here we can factor out, I believe, a negative 16. So we get t squared minus t minus 2. And you get t minus 2 times a t plus 1, it seems. And so your two answers would be 2 and -1. So we could say we have one answer, T1 is 2 and T2 is -1. Now again, make sure you always think when you're doing these problems, because it wouldn't make sense to have a time of -1, at least not in this universe. So we don't even have to care. We don't care about that. We know our answer that we're going to be using is T equals 2. So it takes them about 2 seconds to hit the water. Say 2 seconds later. Now, what is the diver's velocity to impact? So again, the velocity function is the derivative of the position function. So we find the derivative of this equation and then just evaluate it for t equals 5. So let's go ahead, let's find v of t. So v of t is s prime of t. Using the power rule, we did 2 times -16, so -32 times t, and we drop and take away 1 from that power, so times t to the 1, or just times t. Now, since this is 16t, remember this is just like a t to the 0, so the derivative of t is just 1, so this just becomes plus 16. And the derivative of a constant, the derivative of 32 is just 0. So this is your equation for the velocity function. And so now we just find what the velocity is at 2 seconds. So we plug in 2 into here. We have -32 times 2 plus 16. -64 plus 16. So we get -48 feet per second. Oh. All right, and then we're good.